Now that we've covered all of the material, let's look at a summary of classes. So throughout this course, up until this point, we've really looked at the built-in types, integers, floats, booleans, lists, strings, dictionaries, sets. But these don't cover all of our needs, and neither do the ones in the standard library. So occasionally you're going to have to create your own type, and you do that by defining a class like this. So here is our class that we talked about. This creates the car type, has an initialization method. So whenever it is first constructed, this is what will be called implicitly. It has a couple public methods over here as well. So yes, the type is car, but this is really the constructor. We talked about the differences between a type and an instance of that type. So think of the difference between int and say a number like 99. They are completely different. Yes, int constructs integers, just like this car class constructs new car objects, new car instances. And the way to do that is by calling it just like it is a function like this. So whatever is returned, that is your instance. Car, capital C, car, is the class. So whenever you first call it, this special underscore underscore init underscore underscore method will be called. Over here. Here I didn't call this one correctly. You have to pass in all of these arguments that go into it over here. And in the init method, you can have anything that you want. Typically, though, you are going to be setting attributes like this. Over here, we have another instance of a different class being instantiated. We talked about this as object composition. So that's what happens when you first construct it. This is the initialization. So init, think of initialization. Another way to think of this call over here is to think of these constructors as factories. Like just think of it as a physical factory that's producing cars. You just need one factory to produce many cars. They can produce any different cars, and you can customize the car during initialization like this. So then we moved on to creating methods. Methods are functions that are bound to an instance of a class. So this drive method is only available to instances of the car class, just like this future lifetime method is also bound to this class. We talked about this self parameter. This is kind of strange. It's kind of difficult when you first see it. You never actually explicitly pass an argument to the self. Self is, Python will always pass the instance as the first argument to all of these methods. So you never have to provide it yourself. You do have to provide all the other parameters, like miles in this case. One other thing about the init, you don't return anything over here. It will implicitly just return the instance itself. So you never have to have return self like that. Then we talked about the single responsibility principle. So when you create methods, you should think of limiting them to just a single task, usually not too many lines of code. This will help you really break up your code into more digestible pieces and make it easier to maintain and easier to fix. All right, so that is a summary of classes.